There you go. Welcome to Quarkus Insights number 96. That's it, we'll go. Which is a Q&A session, actually, dedicated fully to that. We actually, what's it called? We had an attempt on doing it last week, but then COVID struck on one of us. Well, he's not even here, but yeah, so we postponed it a bit. But we got a bunch of questions coming in on Twitter and GitHub, I think. And we got about 10 of them. And I got Jason. Oh, you're sitting there next to me there. I'm co-leading Quarkus with, and then we have Roberto because there was one very specific one just for you.
Hello. Yeah.
Hello. And that one. And we'll see how it goes. But the idea is that we will go through these questions. But if you have other questions that you want to, come up with during this session, put them in chat, and we will take them there. But we'll see. It's a quiet summer period.
Yeah. Can I jump into questions since I'm the guest?
Sure.
What's anything special happening on the 100th episode? Is that is that a big deal or just a round
So
number?
we actually it all depends on how to see it. We thought about it, but we've been too busy basically. But it looks like we're gonna have there's a team who's done an AI chatbot thing for years, and they just moved over to Quarkus, and it looks like they're gonna be the one. But yeah, we can still make up for things, but we haven't thought about anything.
It's not called Skynet, is it?
Could be. But that was Jules, I thought.
Oh, Jules. Okay.
That's it.
Sorry.
Oh yeah. Yes, you've been on for a while. You've been busy doing work instead of us just sitting here talking. So nothing super special. Maybe I'll get James to make a new color scheme. I don't know, something.
Oh, we can get like balloons 100th anniversary or something like that.
I don't know. Something for yeah. Oh, Erin is live. She's been on vacation. So people out there. Okay, well, let's jump into them. I have them here on. We actually got one that's very appropriate for beginner. So this is Nitish Kumar. I hope you're saying your name correctly. And by the way, I shortened down some of these because we couldn't have more on the screen. But he's talking about what's the ideal path for a beginner to start contributing to Quarkus. That's one, and then he has a note saying the code base is overwhelming, making it hard to get started. Yeah, so I have a few suggestions, but I'll leave it to you guys first. So Jason and Roberto, any tips for Nitish?
Sure. So the first one is kind of, like your stock thing you probably already looked at, but just in case somebody else is curious about this and hasn't seen, there's a contributing guide in the main repo. And you go to our main GitHub repo for Quarkus.io/Quarkus. You read the contributing guide, and it talks about how you get your IDE going, or the little rules like the code conventions and that kind of thing. And from there, my recommendation would be to look for a small issue, like a tiny thing, and then from there try to find where the code is that's related to that. You could look at history. That's like a key thing to do. Like look at history, see past PRs that were related to that. So one thing is you could search GitHub PRs, for example, for the small thing you find. So like say the bug is something like something like the log is rendered incorrectly or something like that. You would be looking at the logging code. And then from there, the way we tend to organize things is we tend to break things apart by extension. So usually once you find the relevant extension, and then you could look at past related changes, and then you could see other files that are interlinked. You'll understand a little bit about how we lay the project out. Roberto, did you have anything you want to add? Any other maybe better tips?
No, yeah, I mean, those are really, really interesting tips because I recently, well, I joined the team like 2 years ago, and I was probably like in a very similar position, right, when I joined, and I did pretty much what you're suggesting, right? So what a couple of things, even though, I mean, when you look at how the person is saying like the Quarkus code is overwhelming, right? Then we don't have a person that pretty much controls the entire code base, right? So sometimes even yourself, you're just familiar to work on a little piece of code, and you have to go and work in some other piece of the code base that you're not familiar with, right? So usually the way that I approach those things is I go to GitHub, look into the pull requests that were changing those specific code bases. One thing that really helps is on your IDE, usually you have some feature on your Git, which allows you to see the history directly on the code base, especially looking who changes the that those particular lines of code, and then you go and check the history also on previous commits around that. So all of those things really help, right? And like Jason was saying, um, all these specific features are usually split on extensions, right? So if you're looking for things like, for instance, Hibernate, then look for Hibernate on the code base, and most likely you're going to find the Hibernate extensions, and everything like with Hibernate is going to go over there. So key things, in my opinion, is look into history, look into PRs, and then search for specific keywords, right, around things that you want to look for. Of course, if you're looking for logging, probably is not really that great because logging is going to be spread around the entire code base, not the core pieces, right? But most likely you're going to find like if you look for log, you're going to find log in all extensions, right? So you have to be very specific on what you're looking for on logging. Maybe search for some specific logging classes that you know that they're going to be instantiated on the logging container, right? So those are the key things that maybe can help you navigate the code base.
And I think I think all your answers were good. One thing I know about Nitish because he actually asked something similar on Sulip chats where he revealed that I think he's a student, like he just basically started developing. Was my impression, and he was trying to, hey, Quarkus is new, exciting. Let's try and go in. And I think for him it was just very like Quarkus is a massive code base. So I would not try and understand the code base from the get go. The first thing I think you want to do is to understand Quarkus. So use our guides, the getting started guide, the very basic ones, just to see what it actually does. Because I'll say the one thing that made me learn anything in a big, oh sorry, not doesn't even a big project, but any project is to have an itch to scratch, like having something I understand. Oh, this, and then realize, oh, I want this to be better. Whether that is different color in logging or a different semantic on how transaction works, it doesn't matter. It's something I want to change, and therefore it's easy to understand. And in case you don't have an itch, so to speak, and just kind of blank and going there. I saw Aaron actually mention a good point here is that we have a label on our issues called Good First Issue, and those are issues that some of us say, hey, this is a kind of a good beginner issue that you can try out. That can give you something to get started. And on that issue, you can ask like, hey, what's this thing about? Maybe I can get started, and someone will give some pointers to it. So yeah.
Yeah, let me just add something else that you remind me when you were talking about. So if you really, I mean, you like Quarkus, and we also like Quarkus. Quarkus is cool, but you also have to remember that Quarkus piggybacks on a lot of features from other libraries, right? So you may want to contribute stuff to Quarkus, and the thing that you want to implement might be sitting on another library. It might be smaller. It might be easier for you to start with, right? So let's just say, I know I'm a little bit biased on this because that's where I work, which is the config stuff. So for instance, if you want to build config stuff for Quarkus, you go and contribute stuff to smallware config, right? Of course, Quarkus will still have some of their config stuff in there, but most of the features are going to be on that library. Same thing for Hibernate. Same thing for REST Easy. Reactive is a different discussion. I'm not going to go into that detail right now. But maybe you may also want to start with some of these smaller libraries that sit around Quarkus, because you can still contribute to Quarkus by contributing to those libraries, and those are also smaller code bases for you to start with.
Okay, that was 10 minutes for question number 1. We have 9 more to go. But yeah, I
That's a
hope it
good
was good.
start.
Yeah. Let's
See,
take,
anytime it involves us getting code from somebody, we'll spend more time on it. No, I'm kidding. No, we welcome everybody who wants to contribute. So thank you for actually for looking into this
yeah,
and wanting
definitely.
to do stuff. This is what makes open source great. Thanks.
Exactly. So let's take an easy one. So Gio I don't know if it's his name, Gio VS or something. On Twitter asked like Quarkus on Windows using VS Code. I've not been able to figure out how to create a native binary or jar. And he's asking for the configuration for it. And I can only guess that you're trying to use VS Code as an IDE, so there's like actions that can do something for you. There might actually be something for this, but the way we've designed Quarkus is that you're not tied to a specific IDE. So whether you use IntelliJ or Eclipse or VS Code, all the basic operations we recommend you to use whatever build tool you're using, whether it's Maven or Gradle in there. So you can look. So I would not go and hunt for how to create a native jar specifically in VS Code, but simply just look in the docs for Quarkus and how you run the Maven and Gradle command for it. Yeah, that's my quick answer to that one. Yeah, you guys have any comments?
Yeah. So the only comment that I usually give to everyone about it is never trust your ID, right? So
Exactly.
never. I mean, not going to details about it, but the point is, there's going to be operations that you want to do on your terminal, and they're always going to work. Well, if they may fail, but sometimes you're going to get in situations where the ID is going to give you a result, and then the terminal is going to give you a different result. And in that particular case, always trust the terminal, because that's the tool that you're building using either Maven or Gradle. Even though the IDEs also use Maven or Gradle, they do some additional things that may seem that your build is passing or they're doing some other crazy stuff. So the bottom line is never trust your IDE. Just do things on the terminal. Sure, IDEs are great to write code, but sometimes they're not trustworthy to build the actual code.
Yeah. And the nice thing with VS Code is actually it doesn't make the terminal a stranger. Like it's kind of built in, so you can just open the terminal and run the commands directly in there, and it plays nice with the terminal. So yeah. Okay, so let's just jump to from a very simple one to a very let's call it maybe I don't know. It could be longer. So this is 1182003841. Very unique username. What's the biggest advance over Spring Native? He has a team. Oh, he's on a team who wants. Oh, sorry. He's on a team and he wants them to use Quarkus, but he doesn't know the advantage of where to get started, and the team already knows about Spring. That was the longer version of his question. So that one, yeah. I have my idea. If I want you guys to jump first.
So I just wanted real quick just to add on to the last question with the IDE thing. You can actually use Quarkus with Notepad and VI.
That is
So
correct.
when we say like it works with any IDE, we actually mean anything that can edit text. And then we make the commands really easy to remember. So like Quarkus dev, and then like to compile native, there's just -d native, that kind of stuff. But anyway, to the question here about Spring Native. So really where Quarkus stands apart is that it was designed to be efficient from the ground up. So basically, if you look at the architecture of a typical framework, most Java frameworks were built to really take advantage of the dynamic capabilities in the JVM, because you could do lots of really cool, powerful stuff, right? You could do dynamic reflection calls. You could do introspection and figure out like what annotations somebody has, and then you could do a bunch of actions based off that work and make all kinds of things happen. Dynamic class loading and all that kind of stuff. That stuff was great for the way in which applications were built when they ran on a big monolith running, on bare metal somewhere. But then things changed with the introduction of cloud, and in particular with container technology and Kubernetes, where the images that you actually run are immutable, and you have an orchestration platform that scales by running lots of really small images. So the challenge is that all that dynamic capability meant that the JVM has a lot of base state. And normally that was shared in that past scenario I was just talking about, those monoliths running on bare metal. But in the case of a cloud architecture, you're running lots of tiny images, or your goal is for them to be tiny, but you're having to keep all this overhead around to be able to do all these dynamic capabilities. So Quarkus was built to not do that kind of thing. Instead, it is built to do things at build time. So everything in Quarkus is build time in advance. And because of that, that allows us to do a lot of things, including having really efficient native compilation. So like the native compiler, it's sort of like garbage in, garbage out. It can only optimize what you give it. So if you give it a bunch of code that's impossible to reason about, like the answer is not known, think of it as an equation where there's like a couple of variables, X and Y. They're not known until after you start the system. Then the optimizer can't reduce it to the number. It doesn't know the answer, so it has to defer it. So it has to keep all the code around. So what Quarkus does is by producing lots of code in advance at build time, specific to what your application is doing, when the native compiler runs, it has the answer. It knows, oh, okay, whenever I inject this bean, there's only one answer. So therefore, I can just inline that whole class. Whereas in the case of other solutions, what might end up happening is likely going to happen, is it's essentially going to take the JVM and put it in a native executable. So what you're going to see is you're going to get disappointed because you're going to compile your application to native. It's not going to be as small as you think it is. It might start a little faster because you're going to get the image snapshotting, so it's going to load the heap right away. But the overall footprint won't be what you like, and it won't fit as well for the modern kube architecture. So sorry for the long answer, but essentially the reason why you would use Quarkus is because we actually optimized your application for running in the cloud, and in particular, even more so in the case of native. These other solutions, they're more about like, how can I take my existing approach, the existing dynamic approach, and then put it in a native executable.
Yeah, and another thing I wanted to add is on the stuff you mentioned that if you take the naive understanding of what you tell you, like, oh, the Quarkus one will have a smaller binary and maybe use a little bit less memory when it runs. But it actually translate into a bit more than that. I'm not sure this blog is out by now, but we are working on one on a history of someone who was testing a Spring app versus a Quarkus app. And he was reporting result that we couldn't add up for us. And it turned out that he was not measuring the actual performance of the app. He was just measuring how fast his write was to his database. But we told him, hey, like, try and, because the thing was that he was loading into the database, and the database was taking all the CPU. The actual application wasn't doing anything. So we told him, hey, try and squeeze the application, like take away resources, like go down to only 30% CPU or something like that. And then the same app, even though that when it runs had good conditions, there was no big difference. But once it got squeezed, which is what happens in the cluster, on the load or because you have whatever resource conflict, we saw that the Spring app was falling over under the squeeze, and this Quarkus app will still perform very well. And of course, eventually it will also fall down. But it meant that with less resources, the Quarkus app was just better in that kind of performance. And that's the thing that people tend to forget. It's not all about image sizes and memory use. It's the whole package combined that makes a big difference. And that's the result you get. Yeah.
One thing I forgot to mention is if you look at past episodes, and maybe you know off the top of your head which one it was, we actually had somebody who came on to share the results of their application, and they had a funny scenario where Quarkus on JVM was actually more efficient than Spring Native, like the results. Now that's not going to be a normal necessarily, but the point is that the savings that we do is for both JVM and for native. So
exactly.
And that stuff really matters for both. It matters for native and it matters for JVM.
And we actually got Rodrigo here asking on the chat something related to this. It says, Our native app recommended for long-lived applications. Here in Brazil, we heard that for long-living apps, we should stay on JVM apps, and that's a question that's hard to give a simple
Yeah.
answer to. But there is truth in what Jason's saying, right? That even JVM on Quarkus is very efficient, and more efficient than general other applications. And the question comes, well, if you've heard us do talks, we generally say that, hey, if you're doing long lived, the JVM generally has a better chance of optimizing because it can optimize while running and figure out, oh, we can do something better. But it all depends on your use case. We had another on the show here talking about that he actually had an ordinary applications running, and he chose native, and he didn't even look at the memory usage. But what he looked at was the fact that he could just scale up like at will because there was literally no overhead of starting up, and it was starting running at native full speed from the get go. So it all depends on your use case. And I don't, yeah. In general, really, yes, you're correct that long-lived applications probably the VM will do better if memory size and general throughput is the important part. But if your application needs to scale up very quickly, whether you have a mix of long running, short running, then native might be the one you choose.
Yeah, my recommendation on that is that you always have to test for those scenarios using
Yes.
your own application, because it's as Max is saying. I mean, generally, that's how we approach things, but you really have to test both scenarios, both VM, both native. It's not only like a 5-minute test. You have to do some performance test over there, check the CPU, check the memory, and see what fits best to you. And one thing that really have to consider is the new versions of GraalVM, because they're optimizing stuff all the time. Especially because it's like a really well, I wouldn't consider it saying as like a new technology, but still a technology that has a lot of things to improve. And what was true maybe 2 versions ago may not be true anymore. So not only have to test your application with the VM mode and the native mode, but you also have to test with different versions, or the version that you're running right now, and maybe the next version that comes up, maybe that's not true anymore, right? So
Yeah.
that those are things you have to consider.
And by the way,
So
you should just to that specific one. Last episode, or was it 2 episodes, we had Sani on, who talked about performance stuff that he's done, and that was a very good example of all the different aspects of things that actually was decent a year ago is now fantastic. Like this was Hibernate Reactive was okay a while ago, but now because of changes, it's now way better than in some use cases than traditional Hibernate. So yeah, Jason, you were saying?
yeah, so I just want to just one thing mentioned specifically is when it comes to like how long your application runs. I think this is a point that people get very confused about. The length of time of the application running really has no bearing at all. Like that, like when you run a Quarkus application in native mode, you typically give it more than one request if you're doing like a microservice type approach. And in the span of processing lots of requests, just because Java is a garbage collected language, you're going to have garbage collection cycles run. The same behavior that you observe in a time span of a minute or two is going to carry forward, continued onward. The JIT can do optimizations, as you guys were just saying. Like the JIT can do optimizations and get like the most optimal runtime performance for the workload that's currently hitting the system. Whereas in the case of native, you're going to get a deterministic output, which I think is the point you were making, Max,
Yes.
is that it's sort of pre-optimized. So you know exactly, like every time you run it, you're going to always get the exact same performance, whereas the JIT needs to warm up. So this is kind of where the long-lived thing comes from is more about challenges in using the JVM than it is about native. So like, as an example, like when you if you're tearing down the JVM because you're doing elastic scalability, so scale down to 0, scale up to say 100 or whatever. So every time you scale down, you're actually tossing that JIT knowledge out the window. So the extra resources that you allocate to support that feature are kind of, I mean, they're not wasted per se, but it's like they're continually churning. Whereas in the native case, you're deterministically, so you're scaling up and scaling down efficiently. So really the thing to think about in that case is the way I would frame it is, are you trying to do a horizontally scalable application, or are you trying to do a vertically scaled node for whatever reason? Right? So like say you have a case where you need 5 gigs of memory, right? Then JVMs could probably be more interesting to you because the memory benefits that you save from native are not really that much in comparison to that gigantic size of heap. It may be like you save, say, half a gig, right? That's not going to be as beneficial. So if the concern is, well, if I run a native application, I have to shut it down all the time. I just want to be clear that's not the case. You can run it for as long as you want to. It's really more about the architecture of your system.
And where things are going is that, for especially for GraalVM, and I know that the GraalVM team is saying that their expectation is in the future native will always beat the JVM, because the native one will spend extra time on compiling everything, whereas the JIT will only compile the stuff that hits a certain threshold. And so you can have some cases, again, it depends on the application, where the JIT has compiled like 99% of your app, but that 1% only get hits a few times, but not enough to trigger the JIT compiler. But that 1% could be exactly the point where you need it to be stable, and therefore JIT will be the one that answers. But basically the same. Another way to respond what Jason's saying is not the length of thing that matters. It's the behavior. It's what your application are doing and what it needs that matters.
Yeah, one final thing to just jump in here on is something that might be surprising is that you can technically have a single instance be slower. Like say a JIT can be, say JIT JVM, it could be like 30% faster, right? But if the overhead of your application says that you can pack in, say, 6 instances in the space of 1, then overall your total throughput will actually be greater, even though each individual instance is slower, because you could just have more of them. So that's horizontal scalability versus vertical scalability. So it's really important to think about what you're doing when you scale out, even if something is slower. So.
Yeah, and I'll just add, so just for this all came out of what are the big events over Spring Native, and you want the team to use Quarkus, but what's that event? So what we talked about, like the runtime and native Graal versus native, Spring Native versus Quarkus Native. If you're on a Spring team or a team that has Spring on others, there's 2 things we normally also say is that, like, the developer experience in Quarkus is generally better, especially our hard reload facilities and dev services, which I think you'll touch on shortly. Is just gives you a faster developer experience, more, we call it developer joy. And the other part is also we have a lot of Spring API compatibility extensions, allowing you to actually take existing Spring code and just, if you have a microservice architecture, just take 1 or 2, port them over to Quarkus, and just see how it is to develop with and to run. The great thing about microservices is you don't have to make everything Quarkus. You can just start one place and let it go from there. Okay, I think we've beaten that horse for a while. And since we talked about native, there was actually a few. Let me see, where was it? Very specific one about native here. Could you show how a native x86 Quarkus image is built via GraalVM on an M1 ARM chip? Sounds like this is a Hambum. I am not going to try to pronounce his name. Forget it. But it sounds like he's in the lucky few that has an M1 chip, but still has to build for a native x86 platform. I can't help there because I'm not one of the lucky few, but I think one of you guys are, at least.
No, me neither.
Then Jason, I guess.
Yeah. So, right. So actually, and the funny thing about that, this is actually part of the reason why we still have a few M1 capabilities that are in progress, is just because of access to the equipment. We even had cases of equipment ordered for developers, and just the supply chain issues, it took quite a bit of time, or it still hasn't come yet. Not that that's a great excuse, but that's honestly like, because it is a different architecture, like having access to it is a really important piece in how we support it. So here's the challenge, though. When you build a native image application, we have the ability to build on binaries for Linux, even though you're on Mac or Windows. But we don't have the ability to do is to change CPU architectures, because the Graal VM compiler is per CPU, so that they don't have a cross compilation capability yet. Maybe in the future that will materialize. So what happens today is, if you try to use the actual container-based native image compilation, which I suspect that's what this issue is talking about. Your container it'll attempt to run, if it's available, an emulation library to run x86. So like typically it's using QEMU user static to do that. And the problem with that is that it's not a perfect emulation layer, and the Graal VM compiler seems to trip it up for whatever reason. I'm not entirely sure why. Maybe one thing I'll look at some point. But even if it did work, it would be very slow in compiling. So if you want to produce an x86 Linux executable and you have it in one, the best thing you could do is actually use CI for that. So you set up a job somewhere, say GitHub Action or Tecton or whatever CI architecture you're using, and you run that on Intel server and produce the binary that way. And you do all your development locally using Java, using JVM mode. That's really what Quarkus is designed for, is to develop with JVM mode. Native compilation is a step you do at the end. You throw it into your CI run, and then compilation times don't really have much impact on you.
Yeah.
You can run Graal VM directly, so you can download the Graal VM in one build, and that will work, but it'll produce a Mac executable, which is most likely what you're not looking for if you're in the primary case of deploying Quarkus to the cloud. Now, that said, you can do a Linux a Linux ARM build using a container. But we don't have an image yet. It's something we're working on. So right now you have to make your own. You have to build your own image. There's a community issue. We could probably link it from the show notes, where people have shared how they're building their image, and from there you can use that from the container image build process. So a bit of a long answer there, but basically bear with us when it comes to M1 capabilities. We certainly care about the support for it. We just have it's highlighted the need for us to do for all of our Quarkus images. We have a bunch of them, need to be multi-arc, supporting Intel and other platforms. And so as we get everything together, it's going to improve the overall deployment, not just for M1, but also for, like, if you're deploying to something like Amazon on their ARM nodes, or you're deploying to some other hyperscaler, we'll have built-in support for that.
Okay, so let's see, what do we have here? There's the one. Another very specific one from Marcos Eckstein. It's a longer one, but I brought it down to, he's wondering, OpenTelemetry instrumentation attribute width span also works for method returning a uni. And he was saying he felt like uni async operations were metered, but there was something with the width span that failed. And this one, I think, is for you, Robert.
Yeah, sure. Yeah, so let's try to not give a too long answer on that. But basically, what's happening is on the OpenTelemetry side, or not only on the basically observability overall, we'll be slowly adding a lot of those capabilities to Quarkus. So one of the challenges that we have right over there is because we want to be able to build everything to native, right? Some of the libraries the OpenTelemetry offers directly. Also, a lot of the things OpenTelemetry does is using a Java agent, which is not supported on native nodes, right? So again, one of the other reasons why we have to do a lot of the integrations on ourselves. So all of that to say that we're slowly adding support to a lot of the OpenTelemetry stuff into Quarkus. So for instance, right now, the width span annotation works in CDI beans and REST endpoints and a lot of other stuff. Now, what happens exactly with this particular use case is when you're calling whatever code with a width span, it creates your trace over there, right? But basically, the width span is implemented with a synchronous interceptor. And once you get your uni, well, then you go to a sync LAN, then the contact is not being propagated with the uni, right? So we already have we are aware of the situation, and usually our recommendation is you can just propagate the contact manually. We know that's not the best use case or the best user experience for that. But for now, that's the recommendation that we have. We had had a couple of issues sitting around for us to implement, and we're working on that to bring all of those capabilities to everything. So again, we're slowly adding. So we started with REST, CDI, REST CDI Reactive already supports all of that, so you can use them with REST CDI Reactive. gRPC was one of the last that we had to support. So we're just slowly adding all of the support over there.
Cool. Let's take another easy one here, or short one, I think. Is HP3 considered in dev in release? From Stephen Mendelman. That's more like a netty level thing, right? You guys have any? Yeah, I haven't kept an eye on HP3, so I'm not.
Me neither, but as far as I know, I mean, there's going to be like a new version with Netty in the next year or so. I have no idea if they're going to add HTTP3 over there or not. But I know they're going to do like they're doing like a big refactor over there with a lot of new stuff. I'm just not sure if they're going to include HTTP3 or not.
Jason, do you know?
I think they're working on it. Yeah, I think they are working on HTTP3 implementation. I mean, certainly when HTTP3 it starts to gain in usage, we know it's coming, so we are going to be taking steps to move forward in the direction of including it. But you could rest assured that when it is actually in main usage, Quarkus will support it. It's something that we had the similar situation, right, with HTTP2, where we had it early, we had it implemented early. I'm speaking generally for our projects in sort of the middleware space, not necessarily Quarkus, which was after HTTP2, but it was similar kind of change. That this is even more so, since you're dealing with a completely different, like non-TCP based delivery mechanism. So it will be coming soon, and we'll probably have like pre-releases where you can enable it. But the frameworks that it comes into place, it needs to come into Netty, and then it needs to get added. We need to have wrapper API support for it in Vertex, and then any special capabilities. From the top of my head, it's been a while since I looked at the spec. I don't think there's a lot that would get pushed to application developers. I'm sure someone who's listening can correct me if I'm wrong. I think it's mostly just like you don't even know it's being used; it just gets used in the background.
Yeah, basically, that's my understanding too. No big, just something about the way you negotiate in the initial conversation is faster. So that's yeah, there's probably more to it. But yeah, so coming soon is the answer to that one. And then we had, where did I lost track here? Oh yeah, here's I think Jason, you prepared one for this one. So Antonio Goncalves, I'm just gonna say Antonio.
Gonçalves.
Yeah,
Gonçalves.
Gonçalves. There we go.
Yeah.
I know he is actually looking into some Azure Quarkus integration and wants to do some dev services. And he actually had raised this question a few times. How do you access dev service from an extension? Before, I know, Jason, you said you had something prepared for it, but I'll just say, for those who don't know, dev service is a feature in Quarkus where we will look at the configuration, and if you are using something like a Postgres or a Kafka or an Amazon S3 or something like that, that is a service somewhere, we will, and you haven't configured which one you want to use, we will start one for you. So and this means that very quickly you don't have to do much. You just have to add the extension or add the minimal configuration to say it's there. It will you can just be playing with it within seconds or even few minutes or even shorter. So that's all what that dev service is, and we have a ton of them, and it's all done by an extension, and that's I think the question is Antonio has like how do you actually do that? So Jason, do you have an example of that?
Yes. So I was just going to suggest. So I just have this is just code from an existing one. Um, the really what's happening under the hood is that with dev services we have we're actually using test containers as the underlying project. So when you write a dev service support in your extension, you'll have some pieces that touch test container where you actually instantiate your container object, and then you can set values like what's the image it's supposed to pull, what parameters is it supposed to take, and then we have some common patterns for ones that are like most of these things tend to be data sources. So like in this case, we have what I'm showing here as an example is basically this is actually from our core code base. This is the Postgres dev service and what it looks like. The architecture of Quarkus is designed such that extensions can communicate with each other, and they establish dependencies between each other. So we have this notion of what's called a build item. And the idea is that an extension can say, I provide a build item. And then another extension can say, hey, I'm interested in this build item. So we actually have facilities that are watching for these dev service configurations. And then when they see one, they use test containers to create the actual container that's specified. So if I scroll down here, you can see that all we're really doing is we're just copying values for configuring our container. So setting the username, the database, image name, and so on. And then all we do is we just instantiate. So we have we're really just creating a class out of our container. Let's see, where's that? So like right here, Quarkus Postgres SQL container. So this just extends the actual Postgres SQL container class from test containers, just to add a few extra values. So that's really all you have to do. It's not really that much to it. If you're looking for where these are, they're in the code base under the extensions dev services folder. So you can see here, there's a whole bunch of them. You can look at MariaDB, MySQL, Oracle, and see how it's implemented. If you want to look at a different approach, like something that's not just a database example, there is a Kafka-based, if you go into the Kafka client area, you can look at that as well. So that's it. It's nothing really complicated. If you're doing a Quarkiverse extension, you would just put this code right in your extension itself. All you're doing is you're just saying, I need a processor, and you could reuse your existing processor. And then you just create a build item for configuring the dev service, and that's it. So I would start with just copy the code from an existing one and modify it up for your database and put it in the project. Take a look at the Quarkiverse project, so Quarkiverse repo for some other examples, and then you're good to go. We should add more docs on this. We don't have it on. Sorry about that. It's on our to do to add more on some of these like extend Quarkus topics.
Yeah, I'll actually gonna try to do that because I'm planning to write a couple of new dev services for the open telemetry stuff. Basically to start the open telemetry collector and Jaeger once you have the open telemetry extension added to Quarkus, because right now we have no way. Well, I mean, you have to start those services on your own if you want to collect traces, right? So that wasn't the plan that I wanted to add to the OpenTelemetry extension. So I'm going to try to take the chance to document that. And if Antonio wants to pair program with me, we can go through that together. And he can look how that is done.
Yeah, I'm sure he will. So we just got a question here about images. DV Singh says, how my application will pull up images where we work behind company proxy and no direct access Docker Hub or public repos. So, well, I'll give my quick there's nothing special about Quarkus here. We use Docker or Podman as theirs, so that Docker or Podman there has to be configured to be able to access proxies. And if I don't think we have, we have images on Docker Hub and public repos, but if your company is shutting, like you don't even have proxy, but you have shut down, then you'll have to update the examples and update the images references to use something that your company will allow. But I'm not sure if you guys can think of anything that
Yeah, I mean the all as far as I remember, all dev services allow you to overwrite the image that you want to use. So if you have one, if you should have at least one image repo on your company, I believe, right? So you can just go over there and just replace it with the one that's approved and allows and available on your company repo, and Quarkus will load from there.
Exactly. And go ahead, Jason. Sorry.
Yeah, I was going to say, like, so if you've configured your container runtime, Podman or Docker, just as Max was saying, and you point it at your internal repo, then you should be able to do just a test run. So you would do your Docker or Podman command and say, like, run Postgres, for example, or pull Postgres. And then if it pulls, then you know that you're actually pulling the official image names. So you got the official images. Then Quarkus will just use that configuration when it starts, because all it's doing is it's talking to the local container instance. It just communicates to it and says, give me an image with this name. And then Roberto's mentioning you can override the name too if you have like a hacked version of it for whatever reason. They're technically dev services. If you write an extension, you can actually start things that aren't containers. We just think the container architecture fits really well, making it easier for developers to clean up. So ideally, your company has put up an internal repo to make image pulling easier.
And I just want to mention it because I've seen this a few times. Like, oh, we can't use Quarkus because it requires Docker for dev services. And I just want to remind people, no, like you can use Quarkus without any Docker at all, as you can use any other framework out there. It's just that one feature, dev services, gets much better if you have access to Docker.
And I'm not sure if I think it's okay to say it. I'm not sure if that's already available to the public yet, but the test container folks, they were working on something called the Test Containers Cloud. So meaning that it will actually create your dev services in the cloud if for some reason you're not able to run them locally. So that's actually a pretty cool thing. Just go over there. I'm not sure if that's already. They gave me like a quick preview like a few months ago. I'm not sure if that's.
It's launched. It is out there. I'm not sure it's GA, but it's definitely out there available for us to try.
Yeah, but look for that, because if for some reason you're not able to run those dev services locally, you'll definitely be able to run them using the Test Containers Cloud.
That is true. Okay. Let's see. Jason, you have anything or?
No, I was just going to suggest that if you run into any issues using Quarkus with containers or images or whatever in a private environment where you find something weird that we do, just let us know, and we would consider it a bug. Basically, it wouldn't be.
Yeah. We
wouldn't intentionally not want to support this use case. We know people are in this situation and would like to make sure that it works.
Yeah, exactly. If as long as you're behind a common proxy, things are going to be more complicated because the stuff that's just how it is. But yeah, Quarkus should work. If it doesn't, then let us know. Okay, let's go to another level here. This is Preslava Chef from GitHub. He's saying, what are you planning for supporting full stack web application development? And he goes on talking about something like Spring Boot is doing more than just container native applications. What are our goals? Something like Renard or Quinoa. So that's in the spirit he's talking. So yeah, you guys have any comments on that one?
So I have an opinion. I'm sure Roberto does too. But so yeah, I mean, basically, like one of the things when we created Quarkus is we really had to set out and target like what's our main need that we're focusing on, and that really, I mean, just to be completely honest, our primary target is cloud native based applications running in Kubernetes, potentially containers as well. We do support bare metal, but primarily we're thinking microservices, right? Like somebody implementing something that's on the back end. But if you look at Quarkus, it's not just that. Like like the Dev Console, for example, is essentially a full stack application. If you go to Code Quarkus.io, that's actually implemented, using Quarkus. We do have some front end technologies that are intermixed. There's a few strategies, like a lot of people like to use Node for their front end technology, so you could mix Node with Quarkus in the back end. You could use Qt is a template library that we have, and it can do cases that maybe previously you would have used JSF for. And then and then Renard is new, and it just shows we are thinking about this this case. Now I can't speak about quinoa. Maybe Roberto, because I've only just read the basic design goals. I've not actually looked at the project.
Yeah, me
I don't know if
neither. Just the basic stuff.
Have we done a session on quinoa with
No,
Insights?
there's actually, I can say, one that is coming up. It's on the 22nd of August, so episode 99. It's going to be the Canoa one. So so that Canoa actually comes from Andy Damwin, who did Quarkus.io. And basically, it's, as you said, if you have Node.js in your project, or you want before Canoa, you had to have your Quarkus backend application configured, set up, and have your Node.js configured, set up, and you have to start one in one terminal, one in another terminal, or whatever you had. And you have to, when changes came in, the whole reload stuff we have in Quarkus kind of not fall apart, but it couldn't see the node side, and the node side couldn't see the other side, so you had to manually keep things in sync. What Kineo does is just kind of removes all that thing. Well, not remove it, it just automates it all. So you can do a change in the front end or the back end, and it will just kind of just work. And we've done it. We've had this philosophy of zero config or almost zero config, and that's what Canoa does. You just I think there's one setting you have to set, and as long as you're using a traditional npm based product or Yarn or whatever, it will just work. So yeah, and about about question about web application framework. So one thing there's basically whether you are, hey, I want to do everything in the back end like Renard and Qt, or everything in the front end like Canoa is. We can also do the stuff in the middle, very much well together. the classics.
Just trying to fix this.
And I'm sure Andy will talk about it more. But one area I'm really personally interested in is in the whole. There's this protocol HTMX, where a very small JavaScript library lets you just annotate HTML, meaning you don't need all the jQuery, React, Angular, JS. You can just have it server-side rendered, and with a little JavaScript in this HTMX, you can do very advanced things purely with a backend application. But we will talk more about that on the 22nd of August, I'm sure. So the question is, are we into web development application framework? Yes, we are. Quarkus is still main priority is they're very noisy, those glasses. So yeah, it's still focused on Kubernetes and performance on the container part, but Quarkus is a generic application framework, so you can use anything for it. So yeah, and I see glasses.
Yeah, it was my glass.
That's why Roberto was. I guess you had a glasses crash there.
Yeah, let me just try to fix them up.
What else do we have here? Did we get through all of them? Oh, there's one more missing here.
Oh, while you're looking for that, one thing you mentioned on the full stack stuff, we have gRPC support, which can be useful if you're doing intercommunication. You don't necessarily want to use. You want to do something that's more protocol heavy, or more quicker interactions, more method call oriented types approaches. So that's useful as well. There's also APIs for WebSockets and things like that. So we have all the pieces that would enable full stack development, but it's not the primary focus. But certainly, if we're looking if people are passionate about it, join the community, and we welcome any kind of ideas on sort of common standards or approaches, guides, things like that, like how
Exactly.
your recommended practice you were successful on. We'll put it on the Quarkus blog. It'd be cool.
Exactly. And episode 99 will have parts of this. Yeah. Well, I actually have. Well, I have two. I have one of this. This is one of the last. This is the last 10th or 9th question that we have from before the talk or before the episode. Again, it's a longer one, but Human Soup was talking about. Can we see how efficient Quark has been running for real world scenarios, like in an extended period over TLS? And I think he had additional comments like, "Oh, we already seen that we have good like first response performance, and tech and power we good in, but." He says tech and power test is like very small payload, so it's not like a real application. And he then says, do we have any test that runs for a longer period of time with more data and that kind of thing? So any comments on that one?
So there was a blog we had a while back on runtime performance where it was a bit more of a involved higher payload scenario. It's definitely things we've tested and continue to test. When it comes to publishing a benchmark, though, there's a pretty big overhead in that, so we don't always do lots of different kinds of benchmarks. We certainly try to publish them; they're topical whenever there's interest. We recommend that you do your own testing, if possible. That way, you're actually comparing, what you're actually using. I can say that all the frameworks that Quarkus uses, even before they were put in, like even before they were in Quarkus, they were in other projects and products, and those have like a long history of being optimized for runtime performance. So, like our transaction library, Neuron transaction library, is was in application servers like EE application servers and ran really well. Our REST framework has been heavily scrutinized with a variety of payload sizes. So yeah, as to TLS in particular, usually when you're involving TLS, you're giving yourself like a constant overhead on top of the baseline for the performance. Sometimes we don't include TLS testing because it just adds, like especially if you're trying to analyze, traffic wise where issues are, it kind of gets in the way and is not necessarily representing what the actual processing that's happening in the actual framework. But it is a constant overhead, so it shouldn't be a significant impact, especially with modern CPUs having instructions for encryption built in. It's not really a great answer, I guess, but I just mentioned that we do testing. We have done in the past. If you look at the Quarkus blog at performance, you'll see at least one article where we're doing larger payloads. And we can look at doing more in the future, but in the meantime, do your own testing.
Yeah, and if you want to publish about it, please do. We prefer not to be the one saying, "Hey, Quark is faster," because we might be perceived as biased, which of course we are. So anyone who's done these kind of testing, please publish them and share the news. That'll be interesting for us and for the whole community. Okay.
Yeah. Well, real quick, sorry, Max. One thing to look out for if you do your own testing is look out for whatever load testing tool you do. Make sure it has its support for avoiding the coordinated omission problem. It's a pretty common problem in benchmarking that can lead to. So, for example, JMeter suffers from this. So, there's updated like WRK2 knows how to deal with this. So, that's the one thing. The one caveat when you do your own testing, make sure that you're using a tool which works for that.
Yeah, and go on Quarkus website. There's a performance guide where we actually talk about how we do our testing and the pitfalls on one of those. I at least added to the doc. I'm not sure it's got merged yet. The comment about the coordinated omission there. So yeah, okay. We actually at the end, but we not accidentally, coincidentally, we had a question coming in on Twitter just before I was shutting down here. From Oliver White, he says, "We all know naming things is hard. How did the name Quarkus get chosen?" That's a very lightweight of. Well, so I wasn't actually around here. I was not doing anything when Quarkus' name was created. So, Jason, do you have the story behind it?
Yes, and you know what's one funny thing is that like every time we talk about it, it's like there's probably like a new
A new
a new
version.
generation of what really happened. Basically the thing is, there was definitely like a nod to physics in this with going like really small. So the kind of the root of of the word is associated with quarks, and then the us part is like the hard problem of developing and solving that and working together. So the two hardest problems in software: getting things small and making things easy to work together. That's like the the answer. I think we had a variety of like name topics. I think we went through something like, I want to say, like, I'm not even kidding. It was like 300 names, like possibilities for what to do. And it's really, if you guys have ever named a project, especially anything that's public, where you have to be concerned about legal stuff, it's like, it, it's a really good luck is my suggestion. It's a tough thing.
Yeah, I love those classes, Roberto.
Yeah, no.
Cool.
So they were mentioning, because I actually changed my profile picture some time ago to go with a picture of Genation that I took over there, because Genations, where we had the Quarkus World Tour this year, we had
Yeah.
like a steampunk team, so we actually offer these glasses to attendees.
Ah,
Uh,
okay.
and so I got one of those as well, and I used them on the keynote. And then for some reason, like, people are now just mocking me all the time.
Well, you also had the hat thing going. So that's
Yeah, no, the hat was actually, he was borrowed from a friend, so I don't actually own the hat.
ah,
So I have to buy a hat, but I do own the glasses.
cool.
Yeah.
Anyway,
By the way, I could add an extra one on there on the Quarkus name thing. The whole
yeah.
supersonic, subatomic Java thing. Um, the uh, the the supersonic might have been inspired by someone listened to a song
But
somewhere
yes.
and was inspired by a quite famous song, in fact. And it fit with the whole like, hey, we're building something super fast and lightweight, and so that's where our tagline, supersonic subatomic
I should
Java,
have
came
queued
from.
up the music now and then go for it. Yeah, that's for sure. But no. Anyway, Roberto, Jason, thanks for coming and helping answering the questions.
It was a
And
pleasure.
thanks for extra questions in from chat. And yeah, so this ends our fourth Q&A. And I'll just, since I had the insights up to find the canoa, I'll just say that next week it's actually cute with Quarkus, with Martin. And the week after is actually Holly coming by to talk about using Minecraft as an observability client. So we'll be playing Minecraft 2 episodes from now.
Cool.
So yeah, so it's actually going to be very much front end the next 3 episodes. So that answers at least one of the questions. Are we looking into front full stack development? Yeah, we are in all different ways and sizes and forms. Cool. We'll end it here, almost on time. So see you next week.